This is SpaceTime, Series 29, Episode 80, for broadcast on the 6th of July 2026. Coming up on SpaceTime, did ancient asteroid impacts prevent Earth's continents from forming? Could the ice giants Uranus and Neptune really be magma worlds? And the world's biggest atom smasher powers down. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that the barrage of asteroid impacts that slammed into the ancient Earth during the Hadean eon between 4.6 and 4 billion years ago may have prevented the formation of the planet's first continents. The findings, reported in the journal Nature, suggest that these collisions may have been the dominating force shaping the early Earth. The continuous rain of asteroid, comet and meteor impacts during this chaotic period delivered vast amounts of heat to the planet's interior, delaying the formation of stable continental crust. The study's lead author, Tim Johnson from Curtin University, says the Earth was hit far more frequently back then than today, with each impact injecting energy deep into the planet. Johnson says, rather than a relatively stable early planet, the findings point to a much hotter, weaker, more unstable Earth. The new research challenges the idea that large impacts were brief events. Johnson says all you have to do is look at the Moon. It preserves evidence of violent times in the early solar system, and those impacts carried enormous amounts of energy, and that energy had to go somewhere. He says the extra heat from impacts would have kept much of the early crust of the Earth weak and partly molten, making it difficult for rocks to survive. At the same time, those conditions would have helped produce more silica-rich crust, which would go on to become the foundations of today's continents. The modelling shows the effects of impacts extended far beyond the moment of collision. See, on the early Earth, much of the energy would have been transferred into the planet's mantle as heat, and that would have caused the mantle beneath and around the impact site to rise and melt, producing huge volumes of magma. The study's results suggest that the early crust was thin and unstable for much of the Hadean. Impacts would have helped keep the crust hot, weak and mobile, while driving melting and recycling on the planetary scales for tens to hundreds of millions of years. The findings also help explain why almost no rocks survived from the first 500 million years of Earth's history, and why the long-lived continents appear to have formed only after the intensity of impacts started to decline. Johnson says it's apparent from the Moon that, by around 3.9 billion years ago, the global effect of impact heating became much less important, which is also around the same time as Earth began to preserve continental crust, and that all seems unlikely to have simply been a coincidence.
I've been thinking about the role of impacts on the Earth for around about a decade or so now. And it really started when I started working on the Moon with a colleague and did a little bit of work calculating how the Moon would have crystallized from a malt to what we see today. And of course, we've spent an awful lot of time and effort and brain power thinking about the Moon, and it's probably one of our finest achievements is to send people there to collect rocks. So we have some lots of quantitative data from the Moon. So we know how old the surface is, which is mainly older than 4 billion years, so Hadean. And you just need to look at that surface and look at them, and you can see what was going on at that time. It was impacts everywhere. There's not 10 square meters of the Moon that hasn't been hit by an impact, and most of it has been hit many times by impacts. So working out what was happening in the Hadean eon on Earth is very difficult because Earth has a very efficient engine, plate tectonic, of recycling that surface. So we don't see this record that we see on the Moon. But you can't just wish it away. It did happen, and we need to think about what the effects of those hugely energetic events was on Earth in terms of individual impacts, but also in terms of the accumulated energy. And that's really what this paper is a accumulation of those thoughts over quite some time.
So it's not just a case of the Earth starting off as a molten sea following the Theia proto-Earth impact, which formed the moon, and then slowly cooling, but there being lots of radioactive elements within the Earth that keeps it warm, but additional heat came from all these impacts.
Exactly. So people have been trying to understand the thermal evolution of Earth for a very long time. And as you said, there's various sources of energy. There is radioactive decay. So very early on, there would have been short-lived isotopes like aluminium-26, which would have been a really big heat source in the early stages in the first few tens of millions of years. And then you have the leftover energy of accretion, of Earth actual coming together. And as Earth cooled down from its molten or semi-molten form, we know the core would have formed. And as that core starts crystallizing, that provides some energy as well. But people have been trying to solve this equation, really, of the heat energy of the Earth, only thinking about these internal sources. And you can't do it. But you can reconcile that energy budget if you think about the energy coming from outside, which is in the form of impacts, of course. And we can see, statistically at least, the impact the Earth would have endured if you just scale up what we've looked at from the moon. So I think it's a pretty robust way of thinking about the early Earth.
And not only do the timescales match the late heavy bombardment, when a lot of the craters we see on the moon and other celestial bodies were formed, it also matches current thinking, current hypotheses regarding when the first continents began to form.
That's exactly right. So continental crust, these pale-coloured granitic rocks that characterise all the land masses that sit above the water, the continents that we live on. We know the oldest continental rock that we have is about 4 billion years old. That's in the Acasta Gneiss complex in Canada. But shortly after that, large tracts of continental crust started appearing in what is now southwest Greenland, and then again in the Pilbara in native Australia, of course, and the Cap Vale in southern Africa. So, yes, we have almost no record for the first 500 million years of Earth history, and then the continents all start popping up together. And I think that is a very simple first-order observation that requires some explanation. Now, I'll challenge you slightly on the idea of the late heavy bombardment. It has been a very popular idea, but many of the ages that it's based on are so-called argon-argon ages that we now know are quite easily reset by impacts. And if we look at the zircon record, which is much more robust in terms of the older events, it seems more likely that we had an exponential decay of impacts from 4.5 to about 3.8 or 3.5. And there might have been a spike in that impact flux around about 3.9, which, as you call the late heavy bombardment. But I think many people would say that was a minor event on top of an overall exponential decline. But like many other things, it's difficult to prove these things. It's so long ago and there's so little evidence.
Well, Jupiter didn't move to its current orbital position overnight. It took a while to get there.
Oh, absolutely agreed. I'm a fan of the swapping over of, I can't remember what the name of that theory is.
It starts with the Nice model and then progress to the JTACT?
Yes, thank you. So yes, I'm very happy that happened. I just don't think, and that would have perturbed the asteroid belt. There would have been, no doubt, an increase in the flux of impacts, but I think it would have been a relatively minor additional contribution on top of the overall pattern. But as I say, who knows what the truth will turn out to be if we can find it.
Tell us more about the Hadean period.
So the Hadean period, in our view, and consistent with our result, was a period where the Earth would have been very, very hot due to this impact heat, and that super hot mantle means that the crust would only have been able to get a few kilometres, perhaps 5 kilometres in thickness. Now, other people, up until now, people have usually considered the Hadean either as a planet not unlike our modern Earth, So there was certainly water on the planet in the Hadean, but some would consider that the Earth cooled down very rapidly and was able to go into a plate tectonic mode of geodynamics, if you like. Not the same as, but similar to what we see today. And the other idea, end member idea anyway, is that the Earth was, because it was much hotter, these things called mantle plumes would have been much more common. So they're these like lava lamp things that raise from deep within the Earth, sort of bubbles of heat that raise up to the surface, and then they drive all the tectonics and magnetism at the surface. But both those models, even though they're very different, they're both just thinking about the internal energy, whereas when you think about the impact energy, the Hadean looks very different. So we would have had a very thin crust. There would have been more or less continuous basaltic magnetism, so dark coloured magnetism, that volcanism we see at Kilauea, Hawaii, those sorts of places. And the ocean would have been very iron rich, so it probably would have been a murky greenish colour. And the atmosphere, no oxygen, of course, and lots of carbon monoxide and dioxide. So that probably would have been a dull, sort of orangey brown hue. Of course, there's no life around, so the Hadean would have looked very, very odd, not at all like the modern planet, in my view.
Apart from the water issue, you're really sounding like you're describing Venus today.
Exactly. Yes. And I think once we get smart enough to do it, and we're getting close now, I think we will find continents on Venus. They won't be quite the same as on Earth, but we will definitely find some buoyant, evolved crust, in my opinion. But let's wait and see what the next few years or decades bring.
That's Professor Tim Johnson from Curtin University. And this is SpaceTime. Still to come, could the ice giants Uranus and Neptune actually be magma worlds? And the world's most powerful atom smasher, the Large Hadron Collider, has been shut down. All that and more still to come on SpaceTime. A new study suggests that the solar system's two ice giants, Uranus and Neptune, might actually be magma worlds. The findings, reported on the pre-press physics website archive.org and submitted for publication in the Astrophysical Journal, are based on new computer simulations by astronomers at the University of California, Los Angeles. Uranus and Neptune are two of the most mysterious worlds in the solar system because only one spacecraft has ever visited them. That's NASA's Voyager 2, swooping by Uranus in 1986 and Neptune in 1989. Their classification as ice giants is based on the hypothesis that their gaseous hydrogen-helium atmospheres cover a vast layered icy mantle composed of water, ammonia and methane surrounding a small rocky core. Problem is, studies of both ice giants' magnetic fields and heat distribution have puzzled scientists because they don't fit in comfortably with that hypothesis. So to work out what's actually going on, the authors used a series of computer models to simulate the likely internal compositions and processes inside both Uranus and Neptune. The new simulations suggest that the interiors of Uranus and Neptune are composed of a magma ocean as opposed to an icy composition. The planetary layers this new study proposes includes the hydrogen-helium atmosphere, which then transports heat to the upper atmosphere and radiates that into space. Below this is a boundary layer composed of hydrogen, helium, magnesium, silicon monoxide and oxygen. And at the base is a magma ocean composed of silicate, iron and hydrogen. Now, the authors admit that while this is just one of a number of models that successfully reproduce the observations featured on Uranus and Neptune, it does have several features in its favour, including the connection with other gas planets. They say it's not clear why gas giants and sub-Neptunes should be fundamentally different simply because of their distance from their host star. The new findings could act as analogues for so-called sub-Neptune exoplanets, that is, planets orbiting other stars which have radii between 1 and 4.5 times that of the Earth. And that's important because sub-Neptune planets are the most common type of exoplanet in our galaxy. Yet there are no similar planets in our solar system, and so their formation and evolution remains a mystery. This is SpaceTime. Still to come, the world's biggest atom smasher powers down, and later in the science report, a new study shows that artificial nighttime lighting has now made planet Earth some 16% brighter at nights. All that and more still to come on SpaceTime. the world's most powerful atom smasher, has been shut down for a 4-year major refit. It's the third major scheduled shutdown for the Large Hadron Collider, the giant particle accelerator beneath the Franco-Swiss border near Geneva. The facility, which is operated by CERN, the European Organisation for Nuclear Research, accelerates packets of subatomic particles at speeds of up to 99.999% the speed of light in two 27-kilometre-long circular pipes guided by cryogenically cooled superconducting magnets. The beams can then be crossed at 4 particle detectors: ATLAS, ALICE, CMS, and L8CB. Each of these detectors are located in a giant cathedral-sized cavern. There, the particle packets can collide, producing pressures and temperatures similar to those generated in the moments after the Big Bang 13.8 billion years ago. The debris produced by those collisions provide new windows into the fundamental laws of nature behind the standard model of particle physics, the foundation stone of science's understanding of the universe. It was the Large Hadron Collider which in 2012 enabled scientists to discover the Higgs boson, a force particle which gives mass to all the other particles through its all-pervasive Higgs field. In the years that followed, the Large Hadron Collider enabled hundreds of major advances, including the discovery of more than 85 hadrons, which are composite subatomic particles made up of quarks held together by the strong nuclear force. It also set exclusion limits on the discovery of new particles, undertook searches into the imbalance between matter and antimatter, explored the nature of the quark-gluon plasma which existed at the start of the universe, and searched for signs of that mysterious substance called dark matter. This so-called high luminosity upgrade will increase the collider's luminosity by a factor of up to 10 beyond its original design, improving its ability to generate high-quality data. See, in particle physics, luminosity measures the rate of particle collisions over time. So higher luminosity increases opportunities to detect rare phenomena, providing clues to new physics beyond the standard model. Currently, the collider's detectors record around 60 proton-proton interactions during each collision. The upgrade will increase that to between 140 and 200. It will also allow the generation of up to 380 million Higgs bosons, a substantial increase on the roughly 55 million that have been produced since the collider first began operations. A key objective of the upgrade will involve detecting rare events where 2 Higgs bosons are created simultaneously. That would allow deeper insights into the behaviour of the Higgs field and offer a new glimpse into the conditions of the early universe following the Big Bang. The shutdown won't be a small event. It'll involve thousands of scientists, engineers and technicians replacing major detector components, including the injectors, installing new timing systems, and upgrading over 1.2 kilometres of superconducting magnets. Technicians will also use this opportunity to carry out essential renovation projects across the entire accelerator complex and experimental facilities, from the consolidation of the new superproton synchrotron North area, the dismantling of the CERN Neutrinos to Gran Sasso target area, and the transformation of the experimental Cavern North 3 into a high-intensity fixed target facility. It's all going to be very exciting and potentially completely change our understanding of the universe. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found that for each extra hour of prolonged uninterrupted sedentary behaviour in a person's day, there's an additional 9% higher risk of death by cancer. The findings, reported in the journal PLOS Medicine, are based on an analysis of data from over 90,000 UK biobank participants who wore activity monitors for a week and were then followed up for around 12 years. Prolonged sedentary behaviour, described as 30 minutes or more during which at least 90% of the time spent sedentary, was linked to a higher risk of cancer incidence and death, obesity-related cancers, and type 2 diabetes-related cancers. Interrupted sedentary behaviour, which lasts less than 30 minutes, or was broken up with more than 10% non-sedentary time, showed the opposite pattern, with lower risks of cancer across all outcomes. A review looking at billions of doses of mRNA vaccines has found that the current vaccinations are both safe and highly effective. When first introduced, there was concern that mRNA vaccines could cause alterations to people's genetic codes. The new research by scientists from the University of British Columbia found the vaccines protected against COVID-19, including severe COVID, in a range of populations, including children, pregnant women, and the immunocompromised. They also found that serious side effects were rare and were substantially outweighed by protection against severe disease, hospitalization, and death. The authors also highlighted the potential of mRNA vaccines to treat and prevent other conditions such as cancer, RSV, and the flu. A new study using satellite data has found that artificial nighttime lighting has made planet Earth 16 times brighter than what it used to be. The findings, based on data from 2014 to 2022, are reported in the journal Nature and include more than 1.1 million individual satellite images. The authors say the growth in artificial light has outpaced population growth. They also found changes in brightness were volatile, with both brightening and dimming indicating periods of construction and demolition, energy instability, such as grid failures in Venezuela, fossil fuel production, and societal disruptions, such as conflicts in the Middle East. A new study has found that sending an electric current through black coffee provides a quick and simple way of measuring its strength and roast. The findings, reported in the journal Nature Communications, claims the test involves applying voltage to coffee and measuring the current passed through it as it responds to the electric field, which allows differences in strength and roast to be calculated. It seems the strength of coffee increases or becomes darker the less electrical charge is generated. The authors say this weakening of the current is due to coffee molecules such as caffeine sticking to the electrodes. Existing methods of testing coffee often involve tasting panels and indirect measurements, which can be both costly and unreliable, or slow, expensive lab tests that look for individual molecules. Lying, dishonest politicians and corrupt, biased journalism have become commonplace in today's world. The rise of misinformation and disinformation has led to what is now a dystopian post-truth era. And for people like you and me who just want the truth, who want to hear the fact without any bias, it's a struggle to easily identify what's verifiable fact and what is simply fabricated. Instead of helping fix this growing problem, our growing reliance on artificial intelligence is actually making the situation worse. As the skeptic's Tim Mendham explains, when it comes to artificial intelligence, like everything else on the internet, it really is a case of garbage in, garbage out.
Yes, this era is regarded as a lot of fake facts sort of areas or debatable truths and that sort of stuff, a post-truth era almost, and that people are finding it difficult to identify what's real and what's not, particularly in medicine areas. Actually, every GP will tell you about people who come in with a picture of a TikTok video or a Facebook post or this sort of thing, and this disease doesn't exist, or here's a better cure for me, etc. What can you do for me? And it's a little like, gee whiz, it's going to take a while to misinform, if you like, people. But the truth is, you can say that's not true. The trouble is people often won't believe that. They don't react well to that sort of thing. So you've got to think of ways of doing it. AI in particular, it can be amplifying facts. It can find facts for you. It can find information for you, or could also misinterpret facts in its own right. It's not purposely lying, but it's just the algorithms in there. It doesn't know. That's the whole problem. And the interesting thing is it is becoming more and more prevalent. I mean, there are stories of best-selling novels which are totally written by AI. There's one that came out fairly recently, a romance novel, I think it was, in the UK, and people said, hang on a second, that looks a bit dodgy, and the author admitted that actually a lot of it was written by AI. There's a recent case of a Australian government inquiry into misinformation in medicine areas, false claims and things, and some of the submissions were written by AI. So, I mean, it's very prevalent. What can you do about it? Very hard. So, obviously from a medical point of view, they suggest that listening is probably better than being dogmatic. People might react better to that. You can try and name misinformation without ridicule. And, if you ridicule your patient, they're going to find another doctor. You've got to be transparent. The thing is, though, discussing with a patient within normal, practice can be difficult because it takes time. So there's a lot of issues with misinformation generally. AI is part of that, not necessarily the evil thing. It's the victim as much as anything else of the information it gathers. It's only as good as the info it picks up, and therefore that's in the algorithms. There are nefarious uses of misinformation, obviously. People selling stuff that may not work, and that's classic for influencers and TikToks and that sort of thing. It's a key problem, and it's very much a problem that doctors are facing increasingly. There are cases these days of people going for medical diagnosis with an AI and preferring that. It seems to be more compassionate by the terms it uses. It's never judgmental, and it's actually written that way, not to be judgmental on purpose. But then you come to the situation where you can actually pull it up on a fact that's quoting and say, that's not correct. And they say, yes, you are right. And you think it backtracks very quickly on false information that it's sort of confronted with.
That's the skeptic's Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to Space Time with Stuart Gary. This has been another quality podcast production from Bytes.com.